We can find acceleration from a velocity versus time graph, similar to how we found velocity from a position versus time graph. Namely, we can take the slope of the velocity versus time, and that should give us acceleration. And this is because, if you remember, my average acceleration is my final velocity minus my initial velocity divided by t2 minus t1, which becomes the derivative. So the derivative at any given point is equal to the slope of that function at that point. Here, I can take any 2 points I want to find this because it's a straight line, so the slope does not change. I'll go ahead and take a point right here, because that looks like my velocity is 0 at time equals 0.5 seconds. And I'll take a point over here. So this will be my v1 is 0, and my v2 is -6, with units of meters per second, as shown over there. So let's plug them in over here, and we get v2 of -6 minus my v1 of 0, with overall units on this of, I guess I can just write it as -6 meters per second minus 0. And then divided by the time intervals, it's 1.5 minus 1.5, 1.5 seconds minus 0.5 seconds. So that's -6 divided by 1 gives you still -6. But now the units are meters per second or meters per second squared. So let's plot that. It's just a constant value. There we go. Acceleration, -6 meters per second squared during this time interval.